Today we will study L'Hopital rule and indeterminate form. Okay, so when you take limit of a quotient like fx over gx, and if fx over gx had indeterminate form, infinity over infinity or 0 over 0, then you can apply L'Hopital rule. So if limit of fx over gx, fx over gx had indeterminate form, then limit of fx over gx equal lim of f prime x over g prime x. So you take the derivative on the top and you take the derivative at the bottom, and then you can take the limit when x go to a, let's say a. Okay, and if f prime and g prime after first derivative it still have the form 0 over 0 infinity, then you can take derivative again, like limit of f second derivative. Okay, so this form is really good to take to apply when you want to take derivative in the quotient. Okay, so first of all, the first condition to fx, suppose fx and gx are continuously and differentiable at a, then you can apply this formula. So first thing you have to check this quotient fx over gx had this form infinity over infinity or 0 over 0, then you can apply this, otherwise you can't. Okay, so now we go to example. Okay, let's make it clear by going through some example. Okay, let's say limit of sin x over square root of x go to 0 plus. Okay, so look at the problem. As you go to 0 plus, that means on the right side of 0. Okay, here 0 here, and if you go from here to here, that will call 0 plus, and if from here to here, that's 0 minus, on the right side of 0 plus. Okay, so if you substitute 0 in here, let's check. Okay, first of all, after we check they are continuous around this point. So the second thing you have to check, do they have this form infinity over infinity or 0 over 0? Okay, then you have to substitute this and you will see that. Okay, so in this case fs, look, fs over gx equals sin x over square root of x. Okay, and if you substitute 0 here, then you have sine of 0 over square root of 0. Okay, sine 0 is 0 and square root of 0, 0. Then you have 0 over 0. Okay, now 0, 0 is indeterminate form, undecided form. So you can apply L'Hopital rule. Okay, so since you have that form, then you can, okay, now you can apply L'Hopital rule. So we have the limit of sin x over square root of x. Let's go to 0 plus. Okay, then will be equal by L'Hopital rule. Then you can take the derivative of the numerator sin x. Derivative of sin x is equal to cosine x. Okay, and then derivative of square root of x. Square root of x, derivative of square root of x. Apply power rule, x square root of x equal x to 1/2, and we have to take the derivative equal 1/2 over x minus 1/2. Okay, 1/2 minus 1, you get minus 1/2. So you have 1/2 x to minus 1/2. Okay, and let's go to 0. Okay, so this thing can be limit of cosine x, and this x minus 1/2 you can convert to the denominator. Okay, you get 1/2 square root of x. Okay, and let's go to 0, and cosine x divided by 1/2 square root of x is become 2 square root of x I cosine x limit. Okay, x go to 0, and if you put limit of 0 in there, then you have limit of 2 square root of 0 and cosine 0. Okay, let's go to 0 plus, and square root of 0, 0, and cosine 0 is 1. So here you have limit of 2 times 0 and times 1 equal 0. So limit of sine x over square root of x go to 0 plus the right side of 0 it will equal 0. Okay. If you don't apply L'Hopital rule, if you take the derivative of sine x and the derivative of cosine, then this side, this form, this quotient is indeterminate form. Okay, it's undecided form. Okay, so you have to apply L'Hopital rule. Let's go to another example. Okay, estimate limit of x cosine x minus sine x over x. X go to 0. Okay, in this case x go to 0. Okay, now if you substitute 0 in here, then you will have if you substitute 0 in here, then you have 0 pi cosine 0 is 1 pi 1, and minus is 0 over 0. 0 times 1 0, 0 minus 0, and divide by 0, so it's the form 0 over 0. Okay. Quotient is have that form and hit continuous around this point. It's continuous around this point. Okay, not at this point. Okay, so we can apply L'Hopital rule. So apply L'Hopital rule. Okay, so if you take, okay, so limit of, take the derivative of that x cosine x minus sine x, take the derivative of numerator and divide by the derivative of denominator. Okay, that goes to 0. Okay, so these two limit of that and equal will be equal this. Okay, now we just take the derivative of this. Okay, the first term of the numerator x cosine x using the product rule, we have limit of, okay, derivative of the first one 1, take the derivative of second one, type the second one cosine x. Okay, and the derivative of this and plus the derivative of the first one and the second one cosine x is minus sine x minus sine x pi x, okay, and then minus sine x. Derivative of x equal 1. Let's go to 0. Okay, now you don't have the from 0 over 0 anymore. Then you substitute and calculate limit of this function when x go to 0. Substitute 0 here. Then you have limit of cosine of 0 minus sine of 0 sine 0 minus sine of 0 over 1 when x go to 0. Okay, sine 0, 0, 0, sine 0, 0. This one equal, this term equal 0. And this equal 0. And cosine 0 is 1. So 1 divided by 1 equal 1. So limit of x cosine x minus sine x divided by x equal 1. So this is a good place to stop right here. This is the answer. Okay, now we go to different example. Well, I have some rules to make to use to make derivative easier, much easier. Okay. Okay, now let's say we have limit of sine of ns divided by x equal n, and x go to 0. Okay, prove this is just another way to ask what is the limit of sine ns of x. Okay, and okay, so this is first of all you have to look, is that quotient or not yet? Numerator equals sine nx and denominator equal x. So x go to 0. Okay, now substitute 0 in here. We have sine of 0 on the top, right? 0 times n 0 sine 0 and the bottom 0. So sine of 0 equal 0 divided by 0. Okay, so they have one of two indeterminate form. Okay, in the indeterminate form. Okay, so you can apply L'Hopital rule. Okay, so you apply L'Hopital into this numerator, denominator. So you have limit of sine nx over x go to 0 will be equal limit of sine nx and take derivative. Okay, and you take derivative of sine nx and also take derivative of x. Okay. Okay, the point of the derivative, you try to get rid of the indeterminate form. Try to get rid of 0 at the bottom. Okay, so the point of L'Hopital rule is to try to get rid of that form. Okay, because that's undecided form, the infinity form, indeterminate form. Okay, so if you take, okay, so here if you take the derivative of the top, make limit of sine s, okay, sine s equal, okay, sine equal cosine ns. Okay, but here it's sine ns, so you have to take using the chain rule, you have to take the derivative of ns to derivative of ns times cosine of ns. Derivative of ns equal n, so multiply by n. Okay, divide by 1. Let's go to 0. Okay, so there you, okay, so you have limit of, so it will equal limit of cosine nx times n, right? Okay, 1 is gone, so x go to 0. Okay, now you can substitute 0 here because since there's no x under the denominator, as to go 0, then you have limit of cosine of n times 0. Okay, as substitute here, you have cosine that, and then times n. Okay, and x go to 0. Okay, n times 0 is 0, so you have limit of cosine 0 multiply n. Okay, x go to 0. Okay, cosine 0 is 1. 1 times n is n. So limit of sine n and s divided by x equal n. We prove it. Okay, we can stop here. This is a good place to stop. Okay, so we're done. Okay, now we go to a different example. Okay, you just apply Hobson's rule. You don't have to remember. You just try to do a lot of exercise, and you will, when you practice it, you will remember it really well. And when you deal with the problem, you will do it really fast. Okay. There are several ways to take limit of quotient, but one of the convenient way and fastest way is Hobson's rule. Okay, let's go to the order. Example, limit of x square, limit of square minus x minus 6 divided by x minus 3. Let's go to 3. Okay, if you substitute 3 in here, then the bottom, the denominator will be equal 0. If you substitute 3, and the top will be 9. 3 square is 9 minus, minus 3 minus 6. Okay, 9 minus 3 minus 6 is 9 minus 9. 9 minus 9 is 0. We have 0 over 0. Okay, so it will become indeterminate form. Okay, so since this has that form, you can apply. Okay, you only check indeterminate form in outside on the graph paper. On the graph paper, don't do it right here. Okay, so now it has like 0. Just put like 0 and 0 form right here. Then apply Hobson's rule. You take the limit of x square minus x minus s minus 6 minus 6 x minus 3 x go to 3 will be equal limit of x square minus x minus 6 take the derivative x minus 3 take the derivative, so x go to 3. Okay, take the derivative at the top and take the derivative at the bottom. Okay, the derivative of x square minus x minus 6 is easy, right? It's 2x, limit of 2x minus 1. Okay, and the bottom is the derivative of x minus 3 is 1. Okay, and x go to 3. Okay, and now you can substitute x equals 3 in here. The limit of 2x minus 1, so x goes to 3, will be equal limit of 2 times 3, okay, minus 1, x goes to 3, 2 times 3 is 6, 6 minus 1 is 5. So the answer of this problem, this limit, is 5. Okay. Okay, if you don't know Hobson's rule, then from this kind of quotient, you can look at this, you can simplify it. The top, since the power of the top is greater than the power of the bottom. You see here, the highest power of the top is square, x squared, and the bottom is x. So you can divide it. You can take x squared minus x minus 6 divided by x minus 3. And when you substitute x minus 3, then you will simplify it. Okay, let's do that way. Okay, this is okay, look at this, x squared minus x minus 6 right here. If you use quadratic form, then you will see this one of the root of this quadratic function is 2 minus 2 and 3. So at the top here you can factor since 6 equal 3 times 2, right? So here you can factor it out, x plus x minus 3 times x plus 2. You can check it, x times x is x squared right here, x, and then minus 3x, minus x, and then x times 2 is plus 2x, and minus 6. Okay, minus 3x plus 2x is x squared minus x minus 6. So this one equal this. So when you factor that out, that will be equal x minus 3 times x plus 2. Okay, divide x minus 3. Okay, so this one equal limit of that x equal to minus 3. Okay, and in this one, get x minus 2 plus x minus 3, you can cancel it. Okay, and you will have the limit x plus 2 x minus 3, x equal to 3 equal. Okay, so substitute here, you have limit of 3 plus 2 equal 5. We got the same answer with L'Hopital rule when we use the L'Hopital rule, but this one a little, trick. You need to see, you need to factor the top, x squared minus x minus 6, and you must have like x minus 3 equal, you can see this, you can see the top also have x minus 3 and the bottom also have x minus 3, then you cancel it. Okay, so if you don't know, you don't see this, that you have to apply straightforward. It's way easier. Okay, or when the top, or you can just divide it. Yeah. Okay, I show you how to divide x squared minus x minus 6 divided by x minus 3. Okay, so here x squared x, so you need to multiply, you need to have x squared, so you multiply by x. Okay, you need here x. Okay, so x times x is x squared. When x times x is x squared, when you move here, it becomes minus. Okay, change the sign when you move this sign, minus x squared. And x times minus 3 is minus 3x, and when you move it here, it becomes plus 3x. Okay, and then add it up. X squared cancel with x squared, and plus 3x minus 3x equal 2x, and 3 minus it down. Okay, now 2x minus 6 divide by x minus 3, so you need plus 2 here. 2x plus 2 times x, okay, 2x, and you have 2 times x is 2x, so minus 2x, and 2 times minus 3 is minus 6, and you bring it here to plus 6. So 2x, add it up, 2x minus 2x equals 0, and minus 6 plus 6 equals 0. Okay, so okay, this one, this divide, this x squared minus x minus 6 divided x minus 3 equal x plus 2. Okay, so it's no remainder, it's perfect division. Okay, so that means we have like we will have x squared minus x minus 6. You can see that you can divide by x minus 3 equal x plus 2. Okay, that's what we get, and then multiply both sides by x minus 3, then you have x squared. So okay, so this thing will be, we replace x squared minus x minus 6 divided by x minus 3 by x plus 2. So we got the same answer. Okay, so we have the limit of that x equal to 3, x squared minus x minus 6 divided by x minus 3 equal x plus 2. Okay, x plus limit of x plus 2. X equal to 3, and put 3 in here, then you still have limit of 3 by 2. 3 by 2, 5 equal 5. Okay, we got exactly the same answer. Okay, now we move to the next example. Limit of x squared minus 16 over x minus 4. Let's go to 4. Okay. Take limit of this. If you substitute 4 here, 4 on the top, 4 square equals 16. 16 minus 16. Okay, and on the bottom, 4 minus 4. So you have 0 over 0. Okay. So you cannot substitute direct. You cannot substitute x equal 4 direct into this quotient, this function right here. You have to apply L'Hopital rule. Okay, so this one will be equal limit of x squared minus 16, take derivative, divide by x minus 4, take derivative, x equal to 4. Okay, derivative of x squared minus 16 will be equal limit of 2x. Okay, and derivative of x minus 4 equal 1. X equal to 4. Okay, so if you substitute 4 in there, so you have limit of 2x, x equal to 4, will be limit of 2 times 4 equal 8. Okay, this problem is very simple. Okay, let's find more complicated example. Okay, if you have find limit of x minus 1 over square root of x squared plus 3 minus 2, x equal to 1. Okay, so here, let's see, if you substitute 1 here, then the top you have 1 minus 1 equals 0. The bottom we have square root of 1 plus 3, 4. Square root of 4 is 2. 2 minus 2 is 0. So it's the form 0 over 0. Okay, so you can apply the L'Hopital rule here. So take limit of x minus 1, take the derivative of numerator and divide the derivative of denominator, x squared plus 3 minus 2, take the derivative, x equal to 1. top derivative of x minus 1 equal 1. Okay, divide by this x squared plus 3 divide the derivative of 2 equal 0. So you just need the derivative of this. Okay, so let's see the derivative of x squared plus 3 square root. This one will be equal x squared plus 3 to 1/2 power, right? And apply power rule, and you have the derivative of that will be equal. Take 1/2 down. You have x squared plus 3 and 1/2 minus 1 go minus 1/2. Okay, and take the derivative. You need to take the derivative of this too. The derivative of x squared plus 3 equal 2x. Okay, so 2 cancel with 2. Okay, and okay, so the final answer will be okay, bring, okay, so you have x right here, x, okay, tie with this x squared plus 3 to negative 1/2. Okay, and bring negative 1/2 to the bottom. You will have x over x squared plus 3. Okay, square root. Okay. Okay, so the derivative of the bottom will be equal x 1 over x divided by square root of x squared plus 3. Okay, so 1 divided by that, just flip it, flip denominator, then you will have okay, so x squared, square root of x squared plus 3, go on the top and then x on the bottom. Okay, and you should do x equal 1 right there, so equal limit of square root of 1 plus 3 divided by 1. Okay, let's go to 1. Okay, limit of square root of 4. Okay, let's go to 1 will be 2. Okay, okay, remember square root of 4 equal 2. Since let's go to 1. Okay, when you say square root, it depends on the limit. Okay, it cannot be equal plus or minus 2. It's just equal 2. Okay, so I think this is a good place to stop, and we will continue on the next video. Alright, so I get now you can take limit very easy. Okay, using apply L'Hopital rule for quotient, and when they have indeterminate form, then you can apply L'Hopital rule. Okay, so I see you next time. To keep practice and do homework, and don't okay, let me take x divide by cx at the form 0 over 0 or infinity over infinity, then limit of fx over gx x go to, let's say a will be equal limit of derivative fx f prime x divided by g prime x go to a. Okay, and fx and gx continuous and differentiable at around that point, about the limit point. Okay, then we can apply L'Hopital rule. Okay, first of all, they must have the indeterminate form, and the second one they must have continuous and differentiable. I mean they can take derivative about the limit point, about that point. Then limit of f(x) over gx when x go to a will be equal to limit of f prime x over g prime x as go to a. Okay. Alright, see you next video. Thank you.